Dissolving sodium chloride in water is an endothermic process. We're asked to answer the following questions. Does the surrounding solution become warmer or colder during this process? Why is the reaction endothermic? And why is the process spontaneous at room temperature? So first we'll go over whether or not the surrounding solution becomes warmer or colder during the process. And the key here is that we're told that the reaction is endothermic. And if a reaction is endothermic, that means in order for it to occur, we need to draw in heat or energy to act as the driving force of our reaction. This contrasts exothermic reactions, which releases energy. And sometimes you may see an endothermic reaction written as A plus B plus heat forms C plus D. And the reason is because heat is an input. This is needed to drive the reaction. You'll also see reactions written as A plus B forms C plus D plus heat, and this is describing an exothermic reaction where heat now becomes an output. So we know this is endothermic, therefore for the reaction to occur, we need to draw in heat from our surroundings. Therefore, our surroundings become colder because we took energy from the surroundings. And now we can talk about the question, why is this reaction endothermic? We're being asked, why do we need heat and energy for this reaction to occur? And the way we can think about this is that to dissolve sodium chloride in water, we need to break bonds. And sodium chloride is a classic example of an ionic solid. So we know that this contains very strong ionic bonds. And in order to break these bonds so we can dissolve the solid in water, we need quite a lot of energy to do so. So breaking bonds requires energy. So therefore, the answer to this question is that we need energy to break bonds. Now we can talk about why this process is spontaneous at room temperature. And so I'll write out the classic formula that relates G, H, and S. We know that delta G equals delta H minus T times delta S. We are told that this process is spontaneous, which by definition means that delta G is negative. We also know that this process is endothermic, which tells us what delta H is. You can recall that for an endothermic reaction, delta H is greater than 0 because we're drawing in energy for the reaction to occur. And for an exothermic reaction, delta H is less than 0 because we're releasing energy. Therefore, delta H is positive in this case. So if delta G is negative, we know that the temperature times delta S has to be a greater number than delta H to make delta G negative. We know that temperature is positive because we're told this occurs at room temperature. And so we know that in order for delta G to be negative, looking at this equation, delta S, or the change in entropy, has to be greater than 0. And so this gives us insight as to why this reaction is spontaneous at room temperature based on the signs of delta G, delta H, and delta S. So our enthalpy increases, our entropy increases, and the Gibbs free energy will decrease.